Welcome to qnawire.
Okay, so for this question, so we can determine the maximum energy of a system, which is the total energy of a system. And then we can determine the angular frequency. And then we can determine the time period and frequency and the maximum speed. So now let's pick the total energy, angular frequency, and time period as the three quantities that to determine for this question. So the total energy should be equal to 1/2 times Ka squared, which is equal to 1/2 times, remember the spring constant is given as 20 Newton per meter. So therefore it's times 20 Newton per meter and then times the amplitude. And the amplitude is given as 0.10 meter. So times 0.10 meter squared. And this will give us the total energy of the system is about 0.1 joule. And the angular frequency, sorry about that, the angular frequency can be equal to square root spring constant over mass, which is equal to square root 20 Newton per meter over the mass, and the mass was given as 0.10 kilograms. So it's over 0.10 kilograms, which will give us the angular frequency is about 14.1 radian per second. And then let's determine the time period. The time period is equal to 2 pi over omega, which is equal to 2 pi over 14.1 radian per second. Oops. And this will give us a time period is about 0.446 second. Okay. And for question B, well, it was saying that the 10% of the mechanical energy was converted into the internal energy during the each cycle. So therefore, we have such equation here, which is 0.9 to the power of n is equal to 1 minus 0.9. Okay, because it was saying 10%. So therefore, the rest of the 90% of the mechanical energy was still working. Okay, so therefore, we'll have 0.9 to the power of n is equal to 0.1. And n here is the number of cycles. And if we do some calculations here, we'll have n is equal to log 0.9 to 0.1, which is about 22, which means that there are still 22 more cycles left before the vibration stop. Okay, and these are the answers for this question.